We are Team 2 of Shunli Catholic Secondary School. Today, we are going to explain how we calculate the speed of the International Space Station by using the camera method. This is the overview of the method we use to calculate the speed of ISS. We use the photo-taking method because the AstroPi operates in a microgravity environment and moves along with the ISS, resulting in no detectable acceleration by either the gyroscope or the accelerometer. Photos of the Earth provide an external reference so that the distance moved by the ISS can be determined. Here are the assumptions we made when doing the calculations. To find the feature points between two photos, we use the ORB and brute force matching method provided by the OpenCV library. ORB is efficient and fast. It can detect key points and compute descriptors quickly. Brute force approach is straightforward and can find the best matches within a short time. Unlike traditional approaches that compute average feature distance for each adjacent image pair, we aggregate all feature distances across the dataset and calculate the median collectively, as it can effectively smooth out the influences of extreme data when the number of photos used are sufficiently large, for example, more than 100 photos. To further minimize the effect of extreme data, we set up two thresholds, which are 0.5 and 1.5 times of the median. Then we filter out data points that are above or below these thresholds and recalculate the median. This makes our calculation statistically more accurate. The unit of feature distance is in pixels. We therefore need to convert it back into real-world measurements using the GSD formula, which is displayed on the screen. Since the image sensor is Sony IMX219, the GSD is approximately equals to 29,672.6. The two photos taken by the camera are in 2D, and the linear distance between the 2 points collected does not consider the Earth's curvature or the altitude of the ISS, resulting in an underestimation. The actual distance between 2 points can be better represented by the arc length as indicated in the diagram. The speed of the ISS can be simply calculated by dividing this arc length by the time difference between the photo pair. Our program features a distinctive function that can identify whether a photo is entirely dark or predominantly blue, indicating a sea with minimal cloud coverage. If we find that the calculated speed deviates a lot from the expected value, that is 7.66 kilometers per second, we will generate an error log that stores the number of photos that are too dark or too few features for determining feature points.